exam days. This is the electromagnetic theory, and this is our first lecture, electrostatic, in which we will learn the Gauss law and its application. So we start with the basics of electronics. In this we will study the properties, the study of the stationary charge, means whether the charge is at a static condition or at the stationary condition. There is another term, that is what source charge, and another is test charge. These are two terms you will see in this chapter. So what is difference? First we will see what is difference between source charge and the test charge. The source charge is due to which event is happening. Okay, charge due to which event is happening. So what does it mean? See, consider any event is there. Event means like this: one charge is at rest, another charge is moving. Okay, so this moving charge is what a movement is there, and due to that movement of this charge there is an effect on this stationary charge. Okay, so this is what we call this stationary charge is the source charge, because what is happening there, this charge, this stationary charge is making certain difference on the charge which is coming. Okay, means the second charge, this one is we can say this is B, this is A. So when B is moving toward A is stationary, or A is considered as source charge, because A is affecting their electric field, force, potential on B. And what is B here? The charge B is a test charge. Test charge is very small charge, that much small that when it is come nearby A, it does not affect the properties of A. For example, it does not going to affect the electric field of A, the force between A and B, because there is certain force between A and B, but it is not influenced by the charge B, because B charge is very small, and that charge is what we call test charge. Clear? So there is a difference between test charge and source charge. So test charge is affected by source charge, but source charge is not affected by test charge, because test charge is very small charge. Okay, now same page we will see what is a charge. So charge is property of matter. What is charge? Charge act as property of matter. Okay, what is the property of matter? If charge is a property of matter, then due to this it has some experience of electric field and magnetic field. So property of matter, due to which there is a magnetic field or electric field or both. And when we talk about the electrostatic, means when we are talking about the charge which is at static condition, it means that the charge when static, it is producing only electric field. There is no magnetic field, because when a charge is in a static condition, it produces electric field. That's why I'm writing magnetic field or electric field. Means sometimes it produces electric field only, and sometimes it produces both magnetic field and electric field. So this is what a charge, where the property is the of matter, and that property, due to that property there is a magnetic field and electric field. So we see the properties of charge. What are the properties of charge? But before that, we know already that there is charges. Charges are of two types: positive charge and negative charge. There is no such neutral charge is there. Why? Because neutral is a condition when equal amount of positive and negative charges are there. Suppose this pen has 10 electrons and 10 protons, then this pen is neutral. it doesn't mean neutral is a charge. So we cannot say neutral charge. Neutral is just a combination of equal amount of positive and negative charge certain body has, which means we have only two charges, two types of charges. One is positive, another is negative. Clear? So first property is the charges conserve, or we can say conservation of charge. Conservation of charge. What does it mean? Conservation of charge. The charge remain conserved in a whole system, in a body. The charge will remain conserved always. Next is quantization of charge. Quantization. What does it mean? Quantization of charge, which means it has some discrete value, not a continuous value. Or a simple thing is that charge does not breakable, means it is always in integer. For example, we know the value that certain body, this one, has 1, 2, 3, 4, 5, 6, 7 or n number of charge, n number of electrons. So total charges will be Ne. Then what is this n? N is always either 1, 2, 3, means in integer. N is what? Integer. So it means that the charge does not available in fraction, means E by 3, E by 2, E by 7, no, not possible. Charge is always a multiple of integer, or it's a property of charge, which is what we call quantization of charge. But when we talk about the quarks, there's a certain different concept. So if we talk about quark, so you see quark is sometimes plus 1 by 3e, minus 1 by 3e. So what does it mean? Or 2 by 3e, or minus 2 by 3e. So what does it mean? The property of quantization of charge get lost? No, there is no property of charge is affected, because there is a certain difference between quark and when we are talking about the body, a charge of a body. And that is the concept is quark does not exist in isolation. So important thing is quark does not exist in isolation. This is the important thing. And when the quark does not exist in isolation, what does it mean? It means the quantization property or quantization concept of charge is not followed by them.